The problem that we are solving today is a word ladder. It is a lead code hard problem. So the problem says that a transformation sequence from word begin word to word end word using a dictionary word list is a sequence of words begin word to end word. So every adjacent pair of word differ by a single letter, and every s of I for I being between 1 to k is in the word list. So note that the begin word does not need to be in the word list, all right? And S of k means the last word, okay, is equal to the end word. Now, given two words, begin word and end word, and additionally word list, return the number of words in the shortest transformation sequence from begin word to end word, or zero if no such sequence exists. So if I look at an example over here, the first thing that I see is we are given a begin word that is hit, and we are given an end word that is cog. And we are given a word list that has all of these words that we can use to reach from hit to cog. Now, if you look at all the strings here, which are like one character away from hit, that would be hot. That is one, because the only character that is different in these two words is instead of this I, we have an O here. So there's one letter different. Apart from that, another word that would be different would be okay, I don't see any other word different here. So hit will only give rise to hot. That'll be the only word that is one character away. Now, when we have go for hot, the words we need to choose next are one character away from hot. So now the character that are one character away from hot are dot. All right. Then we have lot that is one character away, and yeah. So these are the two words that are one character away. So like that, we have to make sure that we are reaching from one word to another word, and we are doing it in the best possible way. Now, the way I see it, the way I've solved this problem is using BFS. What BFS does is basically we're using a queue. Okay, and since we need to find out the return the number of words in the shortest transformation sequence, the keyword here is the shortest transformation sequence. So it basically you need to visualize a tree where the root of the tree is the begin word, and the you have to find out how many steps or how many levels you have to go through before you reach the end word. So that is basically the whole visualization that you can do about this problem. Now, the most critical aspect of this is to basically add the stopping conditions, or to make sure that how do we basically make sure that all characters that are one character away from hit are in the word set or not. So for that, we have to make sure that first we have to create a word set. So this entire word list becomes a word set so that we can do an O of one lookup time. Okay, so whenever we like change hit HIT to HAT, we need to first make sure that if HAT exists in this word set so that we can continue with our processing. So for that processing to be over one time, it's good to make this as a set. Okay, so it takes us just over one time to kind of look up, right? So that is one thing. Now, since we're using a queue, the first word that will be added to the queue would be the begin word. And so we'll be adding the HIT word as the begin word here to the queue. And we'll be initializing the steps to one. Now, the next step, as I mentioned, would be to go over this queue and just find out all the words that are one character away. And that is kind of the biggest challenge in this problem. So, now the way we'll be doing about this is to go over a while loop, and we'll be using an array here where when we go over the while loop, we basically have a number of words that will be there which are already one character away from the current word. So from the current word, the begin word is HIT, right? So now for let word of Q. So when we go over the first array, now we just have HIT over here. That is the only string we have. Now we check if the word is equal to end word, and that is not true. So we don't even go into this condition. The condition that we are interested in is this: I is equal to word dot length, right? And when we go into the word dot length, we have to make again we are going to print all the 26 characters inside the word, right? So the new word will basically be for every character. So it'll be like For HIT, the first 26 iterations inside the word will be like AIT, BIT, CIT, DIT to ZIT. And for the second iteration, it will be like HAT, HBT, HCT, dot 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 to Z HCT. The last would be obviously we're going to HIT. So now it'll be HIA, HIB, and HIC. So when we go over this word list, we'll basically be making sure that word dot slice from the current word plus any random number that we have, random string character from A to Z, okay, plus the remaining characters. So right now it'll be 0 to 0, so this won't be counted, right? Because we don't consider the upper bound on the word. So this string will be responsible for getting all the. So this is the J plus 97. So that basically gives us all the A and the B and the C and the D is till Z, right? And that will basically create that word, create all of these words here. For every word, we have to do very simple processing where we have to check if the word is a part of the word set or not. If it is a part of the word set, then we know that, okay, now we can go ahead with this. So we have to make sure that we put that word into our next array and we delete that word from our word set right now because we don't want to go over that same word again, right? So when we find that word in the word set, we delete that word, we add it to a new array, and before we end that loop, before we end our for loop, right, we make sure that the q is equal to next. So in this case, the first will be like HIT will go to what do we have here? HOT, right? So that will be the only word that we'll be finding out in the word set from all the combinations that we have. So HOT will basically be a part of the queue now, and the next time we'll go over processing will be over queue HOT. So and we'll be incrementing the steps one by one. So that is how this problem is solved. We're basically going 26 into n. Okay, we're going like for every word, and then it is plus that is in multiplied by the length of the queue. So in the worst case, you can have all the words in the queue. So that'll be like, suppose you're taking the string length as m, okay, and every word length as n, and then we have 26. So it'll be like 26 mn. All right, so that is kind of the time complexity of this problem. But since 26 is a constant, that'll be like O of m comma n. All right. And the space complexity, as we see, we have a word set, so that can take up O of n time, O of n space. We have a queue, so that can take up to O of n space in the worst case. So I think the space wise, we are doing O of n. Okay, and n is probably the maximum, the biggest word. Okay, O of n plus O of m, right? We're actually doing both because these are two separate spaces. So it'll be O of n plus O of m, and the max of these would basically be taking up the actual, deciding the actual space time. So that'll be all on this one. Uh, it is a hard problem, but it is a very interesting problem to kind of learn how BFS works, or kind of to also kind of do string manipulation. So it is a very interesting problem, and I'll definitely suggest you to do this. Thank you for watching.